Part I, The Foundation of Workplace AI. Chapter 1, Defining the Intelligence. From Automation to Cognition. This chapter establishes the fundamental vocabulary and conceptual framework for understanding artificial intelligence. Moving beyond popular hype, we dissect the core technologies that power AI and explain their distinct roles in transforming the modern workplace. What is artificial intelligence? Beyond the hype core definition, artificial intelligence, AI, is a broad field of computer science dedicated to creating systems capable of performing tasks that typically require human intelligence. These tasks include learning, reasoning, problem solving, perception, and understanding language. The hype vs the reality. Distinguish between artificial general intelligence, AGI, the hypothetical ability of a machine to understand or learn any intellectual task that a human can, a concept of science fiction for now, and narrow AI, the reality of today's AI, which is designed and trained for a specific task, e.g., filtering spam, recommending a product, recognizing a face. The workplace lens. In a business context, AI is not about creating sentient robots but about building tools that augment human capabilities, automate repetitive processes, and generate insights from data at a scale and speed impossible for humans alone. Machine learning, the engine of modern AI. Core definition. Machine learning, ML, is a subset of AI that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. For every rule, it focuses on the development of algorithms that can access data and use it to learn for themselves how it works. Instead of following static program instructions, ML models are trained on historical data to identify patterns and make predictions or decisions. Workplace analogy. Think of it as teaching a new employee by showing them thousands of past examples rather than giving them a 100-page rulebook. They learn the underlying patterns. Key concept: the quality and quantity of the training data are paramount. A model is only as good as the data it learns from deep learning and neural networks, mimicking the human brain. Core definition. Deep learning is a specialized and powerful subset of machine learning. It uses artificial neural networks, algorithms loosely inspired by the structure and function of the human brain with multiple layers, deep structures. How it works: each layer of the network processes an input and passes its result to the next layer, building up a complex hierarchy of concepts. This allows deep learning models to excel at processing unstructured data like images, sound, and text. Workplace example: a simple ML model might predict sales based on 3 data points: price, season, marketing spend. A deep learning model could analyze thousands of customer review images and texts to predict a product's success, identifying subtle patterns and features invisible to simpler models. Natural language processing, NLP, the art of understanding human language. Core definition. NLP is a field of AI that gives machines the ability to read, decipher, understand, and make sense of human language in a valuable way. Core tasks. It encompasses everything from simple grammatical parsing to advanced sentiment analysis. Key tasks include: natural language understanding, NLU, comprehending the meaning and intent behind text or speech; natural language generation, NLG, creating human-like text from data; workplace applications. This is the technology behind chatbots that handle customer queries, email filters that prioritize your inbox, translation services, tools that summarize long reports, and voice assistants like Siri or Alexa in a meeting room. Computer vision, allowing machines to see. Core definition. Computer vision is a field of AI that enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs, and to take actions or make recommendations based on that information. How it works: using deep learning models, primarily convolutional neural networks, CNNs, computers can be trained to identify and classify objects within an image, and then react to what they see. Workplace applications, manufacturing and quality control, automatically inspecting products on an assembly line for defects. Retail, enabling cashier-less stores where systems track what items customers pick up. Healthcare, analyzing MRI scans and X-rays to assist radiologists in detecting anomalies. Office management, monitoring workspace utilization to optimize office layouts and energy use. Chapter summary. This suite of technologies ML, deep learning, NLP, and computer vision forms the foundational toolkit of workplace AI. They are rarely used in isolation. Most powerful business applications combine them to create intelligent, responsive, and highly effective systems. Understanding what each term truly means is the first step toward leveraging their potential. Part I, the foundation of workplace AI. Chapter 2, the historical context, a brief history of AI in business. To understand the present and future of AI in the workplace, one must appreciate its past. This chapter charts the evolution of business AI from its rule-based beginnings to the data-driven revolution of today, highlighting the key technological shifts that made AI a central pillar of modern enterprise strategy. From expert systems to data analytics. The era, 1980s, early 1990s. The first major wave of commercial AI arrived in the form of expert systems. Core concept: these were computer systems that emulated the decision-making ability of a human expert. They operated by using a knowledge base of human-engineered if-then rules and a logical inference engine to solve specific problems within a narrow domain. Workplace application: they were deployed for tasks like diagnosing mechanical failures, e.g., in telecommunications networks or manufacturing equipment, granting credit authorization by evaluating applicant data against a set of rules, configuring complex product orders, e.g., Dell's early computer configurators. The limitation: expert systems were brittle. They couldn't learn on their own. Their knowledge had to be manually coded by human experts, making them expensive to build and maintain. They failed when presented with scenarios not covered by their pre-programmed rules. The big data inflection point: the era, late 1990s to 2010s. The rise of the internet, e-commerce, and digital connectivity led to an explosion of data. This period marked the shift from rule-based AI to data-driven AI. Core concept: the new paradigm became, instead of telling a computer all the rules, you could show it vast amounts of data and let it figure out the patterns itself using statistical models. This was the broad adoption of machine learning, ML. Key enablers: data availability. Companies began collecting massive data sets on customer behavior, supply chain operations, and financial transactions. Storage, data warehouses. Technologies like Hadoop and cloud storage made it economically feasible to store this big data. Workplace application: this era saw the rise of predictive analytics, forecasting sales, demand, and customer churn recommendation engines. The seminal example is Amazon's customers who bought this also bought, and Netflix's movie suggestions. Basic customer segmentation, using data to group customers for targeted marketing campaigns. The rise of cloud computing and accessible AI. The era, 2010s, present cloud platforms, AWS, Google Cloud, Microsoft Azure, democratized access to powerful AI and ML tools, removing massive barriers to entry. Core concept: companies no longer needed to build their own multi-million-dollar data centers and hire armies of PhDs to experiment with AI. They could rent computing power and use pre-built AI services via API calls. Key enablers: scalable compute power. GPUs and TPUs in the cloud could train complex deep learning models on demand. AI as a service: AI's cloud providers offered pre-trained models for vision, speech, language, and translation that any developer could integrate into an application with just a few lines of code. Workplace impact: this allowed small and medium-sized businesses to leverage AI for the first time. A startup could now add sophisticated image recognition or chatbot capabilities to its product without a massive upfront investment, leveling the competitive playing field. The generative AI breakthrough. The era, 2022, present. The public release of tools like ChatGPT, DALL-E, and Midjourney represented a seismic shift, moving AI from a tool for analysis and prediction to a tool for creation and synthesis. Core concept: generative AI is a class of AI, often based on transformer architecture models, trained on colossal datasets of text, code, and images. It can generate entirely new, original content that resembles human-created work. Key differentiator: unlike previous AI that analyzed data to give an answer, e.g., this customer will likely churn, generative AI uses data to create something new, e.g., write a marketing email to prevent that customer from churning. Workplace impact: this breakthrough is fundamentally altering creative and knowledge work, content creation, drafting documents, emails, and marketing copy, software development, writing, explaining, and debugging code, e.g., GitHub Copilot, synthesis and summarization, digesting long reports, meetings, and legal documents into key takeaways, ideation and design, generating concepts for product designs, advertising campaigns, and business strategies. Chapter Summary. The history of business AI is a story of increasing capability and accessibility. It evolved from expensive, brittle systems for experts to ubiquitous, flexible tools. Powered by data and available to all via the cloud, each era built upon the last, with the generative AI breakthrough representing not just an incremental step, but a leap into a new paradigm of human-machine collaboration. Part I, The Foundation of Workplace AI. Chapter 3, The Ethical Framework, Principles for Responsible AI. The immense power of AI brings profound responsibility. This chapter moves beyond the technical how to address the critical should we. It outlines the core ethical challenges that organizations must proactively address to deploy AI responsibly, build trust with stakeholders, and mitigate legal, reputational, and social risks. Bias and fairness, ensuring equitable algorithms. Core concept: AI systems are not inherently objective, they learn from data created by humans, which can reflect historical and social biases. Algorithmic bias occurs when a system results in unfair outcomes, such as privileging one arbitrary group of users over others. How it manifests: training data bias. An AI resume screening tool trained on data from a male-dominated industry may downgrade resumes containing the word women's, e.g., women's chess club captain. Proxy bias: a loan application algorithm might use zip code as a feature, which can act as a proxy for race or socioeconomic status, leading to discriminatory lending practices. Mitigation strategies: employing techniques like fairness auditing, using diverse and representative training data, and continuously testing model outcomes for disproportionate impacts on protected groups. Transparency and explainability, the black box problem. Core concept: many complex AI models, especially deep learning systems, are black boxes. It can be incredibly difficult to understand why they arrived at a specific decision. This lack of explainability creates risks for accountability, trust, and debugging. The workplace dilemma: if an AI denies a loan application, the applicant has a legal right to know why. If an AI diagnoses a disease, a doctor needs to understand the reasoning to trust it. If a model makes a faulty strategic recommendation, executives need to trace the error. Mitigation strategies: explainable AI, XAI, a field of research focused on creating techniques, like LIME or SHAP, that explain the output of machine learning models in human understandable terms. Principle of right to explanation, designing systems to provide a rationale for their significant decisions, especially those affecting people's lives and livelihoods. Privacy and data security in an AI-driven world. Core concept: AI systems are voracious consumers of data, often including sensitive personal information. This creates massive privacy and security concerns, from how data is collected and used to how it is stored and protected. Key risks: surveillance, using computer vision to track employee productivity in ethically questionable ways. Data inference, AI can infer sensitive information, e.g., health conditions, from non-sensitive data, e.g., purchase history or browsing behavior, violating contextual privacy norms. Security breaches, vast centralized datasets used for AI training are high-value targets for cyber attacks. Mitigation strategies: adhering to privacy by design principles, complying with regulations like GDPR and CCPA, implementing strong data anonymization and encryption techniques, and being transparent with users about data collection and usage. Accountability: who is responsible when AI fails? Core concept: as AI systems make more autonomous decisions, assigning legal and ethical responsibility, liability, becomes complex. The accountability gap asks, who is to blame when a self-driving car crashes, a trading algorithm causes a flash crash, or a biased hiring tool discriminates? The chain of accountability, responsibility can span multiple parties: the developers who designed and trained the algorithm, the company that deployed it, the users, e.g., employees, who operated it without proper oversight, the executives who approved its use, mitigation strategies, establishing clear governance frameworks from the outset. This includes defining human oversight roles, creating channels for redress, and ensuring there is always a human in the loop for critical decisions. Establishing an AI ethics board. Core concept: a proactive, structured approach to managing AI ethics is not a solo endeavor. An AI ethics board or committee is a cross-functional governance body tasked with overseeing the ethical development and deployment of AI within an organization. Purpose and mandate: this board moves ethics from an abstract concept to an operational reality. Its role is to develop and enforce a company-wide AI code of ethics, review and approve high-risk AI projects before they are launched. Conduct ethical impact assessments, similar to environmental impact assessments, serve as a central forum for addressing ethical dilemmas and incidents. Composition: to be effective, the board must include diverse perspectives, legal and compliance, data science, engineering, product management, marketing, HR, and external ethicists or community representatives. Chapter summary: ethical AI is not a constraint on innovation but its essential foundation. Building trustworthy, fair, and transparent systems is a strategic imperative that protects the organization and ensures technology serves humanity. A robust ethical framework, championed from the top and embedded into the development life cycle, is the hallmark of a mature and responsible organization in the age of AI. Part 2, AI in Practice, Functional Applications. Chapter 4, the AI Augmented Employee, Enhancing Human Capability. This chapter shifts the focus from organizational systems to the individual. It explores the most personal dimension of workplace AI, how it acts as a powerful tool to augment human intelligence, automate mundane tasks, and free up cognitive capacity for strategic, creative, and empathetic work. The central thesis is that the most powerful form of AI is not autonomous, but collaborative. AI as a collaborative partner, not a replacement. Core concept: the most effective and sustainable model for AI in the workplace is augmentation, not automation. This philosophy, often called human-in-the-loop AI, positions artificial intelligence as a collaborative partner that handles data-heavy lifting and pattern recognition, allowing humans to focus on higher-order judgment, creativity, and interpersonal skills. The analogy: think of a pilot and an autopilot system. The autopilot manages routine flight, navigation, and systems monitoring, but the human pilot is essential for strategy, handling emergencies, and making complex ethical decisions. AI is the corporate autopilot. Workplace impact: this mindset reduces employee anxiety and fosters a culture of adoption. The goal is not to create a fully autonomous employee but to create a bionic workforce where human and machine strengths are combined to achieve better outcomes than either could alone. Tools for personal productivity, scheduling, email, and note-taking. Core concept: this is the most widespread and accessible layer of AI augmentation, often embedded directly into the software employees use daily. It focuses on automating administrative overhead and managing cognitive load. How it works and examples: scheduling, AI tools, e.g., Zay, Clockwise, Microsoft Copilot in Outlook, analyze calendars across an organization to find optimal meeting times, resolve scheduling conflicts, and even draft polite scheduling emails. Email, AI prioritizes inboxes, e.g., Gmail's important filter, suggests quick replies, summarizes long email threads, and drafts full emails from bullet point prompts. Note-taking and transcription, tools like Autorai, Microsoft Teams transcription, and Firefly Say join meetings, transcribe conversations in real time, identify different speakers, and generate actionable summaries and key takeaways. The value proposition: these tools reclaim hours per week for every knowledge worker, reducing context switching and allowing deeper focus on core job functions. AI assistants and copilots for knowledge work. Core concept: moving beyond simple productivity, AI copilots are integrated directly into professional software to assist with complex, domain-specific knowledge work. They act as an always available junior partner or expert consultant. How it works and examples: coding, e.g., GitHub Copilot, Amazon Code Whisperer, suggest entire lines or blocks of code, translate code between languages, write unit tests, and explain what a complex piece of code does. Writing and content creation, e.g., ChatGPT, Jasper, Copy assist in drafting reports, creating marketing copy, generating ideas and polishing grammar and tone for different audiences. Data analysis, e.g., Microsoft Copilot in Excel, Tableau GPT analyze data sets, create pivot tables, suggest formulas, and generate natural language explanations of trends and charts from simple text prompts, e.g., what were our top-selling products in Q3? The value proposition, these copilots dramatically accelerate execution, reduce beginner-level errors, and help experts overcome creative blocks, effectively elevating the skill floor for all users. Upskilling and reskilling for the AI era workforce. Core concept, as AI transforms the nature of work, the skills that are valued will also shift. Organizations have a strategic and ethical imperative to invest in continuous learning to prepare their workforce for new, augmented roles. The shift in skills, less demand for manual data processing, routine analysis, memorization of procedures, more demand for AI literacy, understanding how AI works, its limitations, and how to interact with it effectively. Critical thinking and evaluation, the ability to assess, critique, and validate AI-generated outputs, e.g., is this code secure? Is this marketing copy on brand? Prompt engineering, the skill of crafting precise instructions and questions to get the best results from generative AI models. Human skills, creativity, strategic thinking, emotional intelligence, negotiation, and leadership, areas where humans still vastly outperform AI. The role of the organization, companies must create clear pathways for reskilling, provide access to training platforms, and incentivize employees to develop these new muscles, ensuring that augmentation leads to empowerment, not displacement. Chapter summary, the future of work is not humans versus machines, but humans with machines. The AI-augmented employee is more productive, less burdened by tedium, and able to focus on the uniquely human aspects of their role. Success in this new paradigm depends on both adopting the right tools and committing to a culture of continuous learning and adaptation. Part 2, AI in Practice, Functional Applications. Chapter 5, Revolutionizing Operations and Productivity. This chapter delves into the core of the enterprise, its operational backbone. Here, AI moves beyond assisting individual knowledge workers to optimizing entire systems and processes. The applications in this chapter are primarily focused on automating complex workflows, deriving intelligence from unstructured data, and making entire value chains more efficient, resilient, and cost-effective. Intelligent Process Automation, IPA. Beyond robotic process automation, RPA, core concept, intelligent process automation, IPA, is the evolution of robotic process automation, RPA. While RPA is a digital workforce of software bots that mimic human actions to execute repetitive, rule-based tasks, e.g., data entry, copying between systems, IPA infuses these bots with AI to handle unstructured data and make simple decisions. The key difference, RPA does what it's told. It follows a strict, predefined script. Copy this number from field A in application X and paste it into field B in application Y. IPA does what it thinks it can handle. Variation: read this incoming invoice, a scanned PDF, extract the vendor name, invoice number, and total amount, using NLP and computer vision, validate it against the purchase order, and only if it matches, then enter it into the ERP system for payment. Workplace application, automating complex, end-to-end processes in finance, invoice processing, HR, onboarding paperwork, customer service, processing refund requests, and compliance document processing. And management with AI. Core concept, businesses run on documents, contracts, reports, invoices, forms, and manuals. Most of this information is unstructured. AI, specifically natural language processing, NLP, and computer vision, can read, interpret, classify, and extract valuable information from these documents at scale. How it works and examples: data extraction, AI can pull specific clauses from a legal contract, extract line items from a receipt, or capture information from a filled out Application form classification and routing. An AI system can read an incoming email, identify it as a customer complaint or a sales lead, and automatically route it to the correct department or queue. Semantic search. Instead of just searching for keywords, AI-powered search understands the meaning of a query. For example, searching a vast database of technical manuals for how to fix a leaky valve returns precise instructions, even if the exact phrase isn't written anywhere. The value proposition transforms static documents into dynamic, searchable, and actionable data, unlocking insights trapped in filing cabinets and digital folders and drastically reducing manual review time. AI in supply chain and logistics. Predictive forecasting and optimization. Core concept: the supply chain is a complex, interconnected system ripe for AI optimization. AI models use vast internal and external datasets to predict disruptions, optimize routes, and manage inventory with unprecedented precision. How it works and examples. Predictive demand forecasting analyzes historical sales data, market trends, weather patterns, social media sentiment, and even macroeconomic indicators to predict future product demand far more accurately than traditional methods. Optimizing production and inventory levels. Smart logistics and routing. AI algorithms optimize delivery routes in real time, factoring in traffic, weather, fuel costs, and delivery windows. This is how companies like Amazon and UPS promise precise delivery times. Predictive maintenance analyzes sensor data from trucks, ships, and warehouse machinery to predict equipment failures before they happen, scheduling maintenance to avoid costly downtime and delays. The value proposition creates a resilient, efficient, and responsive supply chain that minimizes costs, reduces waste, and maximizes customer satisfaction. Smart manufacturing and the Internet of Things, IoT. Core concept: this is the application of AI on the factory floor. By connecting physical machinery with sensors, IoT, manufacturers create a digital stream of data. AI analyzes this data to optimize the entire production process in real time, a concept often called Industry 4.0. How it works and examples. Quality control. Computer vision systems on assembly lines can inspect thousands of products per minute for microscopic defects that are invisible to the human eye, ensuring consistent quality. Process optimization. AI models analyze data from sensors on production equipment to find the optimal settings for temperature, pressure, and speed to maximize output and minimize energy consumption and material waste. Generative design. Engineers input design goals and constraints, e.g., weight, strength, material. AI algorithms then generate hundreds of potential design options, often creating highly efficient, organic structures that a human would not conceive of. The value proposition drives unprecedented levels of efficiency, quality, and customization in manufacturing, moving towards lights-out factories that can operate with minimal human intervention. Chapter summary. In the realm of operations and productivity, AI acts as the central nervous system for the enterprise. It connects disparate data sources, automates not just tasks but entire cognitive processes, and provides a predictive lens for future events. The result is an organization that is not only faster and cheaper but also smarter, more agile, and more resilient to disruption. Part 2, AI in Practice, Functional Applications. Chapter 6, The AI-Powered Customer Experience. This chapter explores the customer-facing frontier of AI. No longer confined to back-office operations, AI is now a primary engine for acquiring, engaging, and retaining customers. It enables businesses to move from mass, impersonal interactions to hyper-relevant, predictive, and seamless experiences that build deep loyalty and trust. Hyper-personalization, tailoring products and marketing. Core concept: hyper-personalization uses AI to deliver tailored content, product recommendations, and experiences to individual users in real time. It goes beyond simple segmentation, e.g., for women under 30, to treat each customer as a market of one. How it works: AI models analyze a user's real-time behavior, historical transactions, demographic data, and broader cohort patterns to predict what they will want next. Examples: dynamic websites and apps, Netflix's homepage, Amazon's product recommendations, and Spotify's Discover Weekly are all powered by AI that curates a unique interface for every single user. Personalized marketing, AI can generate thousands of unique email or ad variants, each tailored to a recipient's likely interests, leading to significantly higher engagement and conversion rates. Adaptive products, fitness apps that generate custom workout plans, or news apps that curate article feeds based on a deep understanding of a user's reading habits. The value proposition transforms customer interactions from generic broadcasts into relevant conversations, dramatically increasing engagement, customer lifetime value, and brand loyalty. Chatbots and virtual assistants for 24/7 customer support. Core concept, AI-powered chatbots and virtual assistants use natural language processing, NLP, to understand customer queries and provide instant, accurate responses or actions, anytime and anywhere. Evolution, this field has evolved from simple, rule-based menu bots, frustrating, to sophisticated conversational AI that can understand context, intent, and nuance. How it works and examples. Tier 1 support, handling frequently asked questions, FAQs, tracking orders, processing returns, and resetting passwords. This resolves up to 80% of routine inquiries instantly, freeing human agents for complex issues. Intelligent routing, the chatbot accurately understands the customer's problem and routes them to the most qualified human agent, along with a summary of the issue, reducing transfer times and customer frustration. Voice assistants, AI-powered phone systems, IVR, that can understand natural speech and solve problems without pressing 1 for sales, 2 for support. The value proposition provides instant, scalable, and cost-effective customer service, improving satisfaction and operational efficiency while lowering support costs. Sentiment analysis, understanding customer emotions at scale. Core concept, also known as opinion mining, sentiment analysis is an NLP technique that identifies and extracts subjective information from text to determine the emotional tone behind a message, positive, negative, or neutral, and often to a more granular degree, e.g., angry, happy, frustrated, satisfied. How it works, AI models are trained on vast datasets of text labeled with emotions to learn the linguistic cues associated with different sentiments. Workplace applications, brand monitoring, analyzing social media mentions, reviews, and news articles in real time to gauge public perception of a brand or product. Launch customer support prioritization, automatically flagging support tickets or social media messages that contain high levels of anger or frustration for immediate human intervention. Product feedback analysis, analyzing thousands of product reviews to automatically surface common pain points and praises, providing invaluable, aggregated feedback to product development teams. The value proposition moves beyond what customers are saying to understand how they are feeling, providing a crucial, real-time pulse on customer sentiment that can guide PR, product, and support strategies. Predictive customer service, solving issues before they arise. Core concept, the pinnacle of customer experience is proactive service. AI enables companies to predict which customers are most likely to encounter a problem and reach out to solve it before the customer even knows it exists. How it works, AI models analyze patterns from vast datasets to identify precursors to common problems. Examples, a telecom company's AI detects a pattern of signal degradation from a customer's router and automatically dispatches a technician before the customer calls to complain about slow internet. A software company's AI identifies that a user is struggling with a specific feature based on their usage patterns and automatically sends them a tutorial video or offers help from a specialist. A bank's AI flags a potentially fraudulent transaction and sends an instant verification request to the customer, preventing a larger issue and building trust. The value proposition transforms the customer relationship from reactive to proactive, creating wow moments that generate immense goodwill, drastically reduce complaint volumes, and increase customer retention. Chapter summary, the AI-powered customer experience represents a fundamental shift from transactional to relational interactions by leveraging AI for personalization, instant support, emotional intelligence, and predictive care. Businesses can create a seamless, intuitive, and deeply valuable experience that not only satisfies customers but delights them, building a durable competitive advantage in the process. Part 2, AI in Practice, Functional Applications Chapter 7, Data, Insights, and Strategic Decision-Making. This chapter addresses the pinnacle of AI's value proposition, transforming raw data into a strategic asset. Here, AI moves beyond automating tasks and personalizing experiences to become a core advisor to leadership. It empowers organizations to shift from reactive, gut-feel decision-making to a proactive, evidence-based approach, uncovering hidden opportunities and mitigating unseen risks. Advanced analytics and predictive modeling core concept. This is the application of AI and machine learning to analyze historical data in order to make predictions about future outcomes. It represents a quantum leap beyond traditional descriptive analytics, what happened, to predictive, what will happen, and prescriptive, what should we do about it. Insights, how it works. Algorithms identify complex, nonlinear patterns and relationships within vast data sets that are impossible for humans to discern. They then use these patterns to forecast future events with a quantifiable degree of probability. Workplace applications. Predictive analytics, forecasting customer churn, sales revenue, equipment failure, and inventory demand. Prescriptive analytics, not just predicting an outcome, but recommending specific actions to achieve a desired result. For example, customer X has an 85% chance of churning, but offering them a specific discount package would reduce that risk to 25%. Customer lifetime value, CLV, modeling, predicting the total value a customer will bring to the business over their entire relationship, allowing for optimized marketing spend and retention strategies. The value proposition moves the organization from hindsight to foresight, enabling proactive strategy and resource allocation. AI-driven business intelligence. By dashboards core concept. Modern AI is revolutionizing traditional buy dashboards. Instead of static reports that require users to manually explore and interpret charts, AI-driven dashboards are interactive, conversational, and insightful. They don't just show data, they explain it, how it works, and examples. Natural language query, NLQ, allows users to ask questions of their data in plain English, e.g., why did sales in the Midwest drop last quarter? The AI interprets the question, queries the database, and returns an answer in the form of a narrative summary and supporting visualizations. Automated anomaly detection. The AI continuously monitors all incoming data and automatically flags significant deviations from expected patterns, e.g., a 15% spike in website traffic from Germany is occurring right now, and alerts relevant personnel. Smart data storytelling. The AI generates automatic commentary on reports, highlighting key trends, outliers, and potential causes, turning a spreadsheet into a compelling narrative. The value proposition democratizes data access, allowing non-technical managers and executives to get immediate, actionable answers without relying on data analysts, dramatically speeding up the decision-making cycle. Competitive intelligence and market analysis core concept. AI can continuously and automatically monitor the external digital environment, including competitors, market trends, news, and regulatory changes, to provide a comprehensive and real-time view of the competitive landscape. How it works. AI tools use web scraping, NLP, and sentiment analysis to process millions of data points from news sites, social media, financial reports, job postings, and patent filings. Workplace applications. Competitor analysis, tracking competitors' pricing changes, product launches, marketing campaigns, and customer sentiment in real time. Market trend spotting, identifying emerging consumer trends, new technologies, or shifting regulatory demands before they become mainstream. M&A and investment scouting, scanning the market for potential acquisition targets or investment opportunities that fit specific strategic criteria. The value proposition provides a sustained competitive advantage by ensuring strategic decisions are informed by a complete, up-to-the-minute understanding of the market, reducing the risk of being blindsided by competitors or market shifts. Scenario planning and risk management with AI simulations core concept. AI can run complex simulations or digital twins of business operations, market conditions, or global supply chains. This allows leaders to stress test strategies under thousands of different potential future scenarios, e.g., a raw material price shock, a new competitor entering the market, a pandemic, to identify risks and optimal paths forward. How it works: based on historical data and defined variables, AI models simulate outcomes for countless what-if scenarios, quantifying the potential impact and probability of each workplace applications, financial stress testing, modeling the impact of economic recessions, interest rate changes, or currency fluctuations on the company's financial health. Supply chain resilience planning, simulating disruptions, e.g., a port closure, a supplier bankruptcy, to identify single points of failure and develop robust contingency plans. Strategic planning, evaluating the potential outcomes of entering a new market, launching a new product, or making a major capital investment under various market conditions. The value proposition transforms risk management from a defensive, reactive exercise into a strategic, proactive capability. It allows organizations to make decisions with a clear understanding of the potential downsides and upsides, building resilience and strategic agility. Chapter summary: in the realm of strategy and decision-making, AI acts as a force multiplier for human intellect. It processes complexity at a scale beyond human capability, revealing causal relationships and future probabilities that would otherwise remain hidden. By integrating AI-driven insights into the core strategic process, organizations can navigate uncertainty with greater confidence, allocate resources with greater precision, and ultimately build a sustainable future based on data, not just intuition. Part 2, AI in Practice, Functional Applications. Chapter 8, Innovation, Creativity, and Content Creation. This chapter explores one of the most paradigm-shifting applications of AI, its role as a catalyst for innovation and a collaborator in the creative process. By democratizing tools for design, writing, and research, AI is breaking down traditional barriers, accelerating the pace of creation, and enabling human professionals to explore vast new territories of ideas. Generative AI, a new tool for human creativity. Core concept: generative AI refers to algorithms that can create new, original content such as text, images, audio, and video based on the patterns and structures learned from their training data. It is not a replacement for human creativity but a powerful new medium and collaborator. The philosophical shift: this moves AI's role from analytical, understanding and interpreting existing data, to generative, producing novel data. It acts as an infinite idea generator, a first draft creator, and a source of inspiration. The collaborative model: the most effective use of generative AI is a partnership. The human provides the creative direction, context, and critical judgment, the why and the what, and the AI provides rapid execution, variation, and scale, the how. The value proposition: it dramatically reduces the blank page problem, accelerates iteration, and allows creators and innovators to explore possibilities that would be too time-consuming or costly to attempt manually. AI in design, generating concepts, mock-ups, and visuals. Core concept: AI tools are transforming the design workflow. From initial concept ideation to final asset production, they assist in generating visual concepts, layouts, and variations at an unprecedented speed. How it works and examples: concept ideation: designers can use text-to-image models, e.g., Midjourney, DALL-E, Stable Diffusion, to generate hundreds of visual concepts, mood boards, and style explorations from simple text prompts, e.g., logo for a sustainable coffee shop, minimalist, leaf emblem, UI/UX. And mock-ups: AI tools can generate functional website and app mock-ups from a text description, suggest UI improvements based on best practices, and even generate front-end code from a design mock-up. Asset production: automating the creation of marketing materials in multiple sizes and formats, generating pattern variations for products, or creating custom illustrations for articles. The value proposition: frees designers from tedious production work, allowing them to focus on high-level strategy, user experience, and art direction. It drastically shortens the time from idea to visual prototype. AI for writing and content generation, drafts, marketing copy, and code. Core concept: generative AI is a powerful writing partner across numerous domains, capable of drafting, summarizing, translating, and ideating text-based content. Its impact is felt from marketing departments to software engineering teams. How it works and examples: drafting and editing, assisting in writing emails, reports, and articles by generating first drafts, expanding on bullet points, rewriting sections for clarity or a different tone, and correcting grammar. Marketing copy, generating high-volume, SEO-optimized product descriptions, social media posts, email campaign copy, and ad variants that can be A/B tested. Code generation and assistance, tools like GitHub Copilot act as an autocomplete for code, suggesting whole lines, functions, and blocks of code. They can write code from natural language comments, e.g., write a function to sort this list by date, translate code between programming languages, debug errors, and write unit tests. The value proposition overcomes writers' and coders' block, ensures consistency in tone and style, increases output velocity, and handles repetitive coding tasks, allowing professionals to focus on complex logic, narrative structure, and strategic goals. Accelerating research and development, R&D. Core concept: AI is becoming an indispensable partner in scientific and product R&D by analyzing complex data, generating novel hypotheses, and simulating outcomes, thereby accelerating the path from discovery to development. How it works and examples: literature review and synthesis. AI can read and summarize thousands of scientific papers, patents, and technical reports to identify emerging trends, connections between disparate fields, and gaps in knowledge. Hypothesis generation: by analyzing vast datasets of experimental results, AI can suggest new, non-obvious research avenues or potential compounds for drug discovery that a human might overlook. Simulation and modeling: AI can run millions of digital simulations to test the properties of new materials, chemical compounds, or mechanical designs before any physical prototype is built, saving immense time and resources. This is crucial in fields like pharmaceuticals, materials science, and aerospace engineering. The value proposition reduces the time and cost of the innovation cycle, increases the probability of breakthrough discoveries by exploring a wider solution space, and helps researchers stay atop the exponential growth of scientific literature. Chapter summary: the integration of AI into creative and innovative processes marks a fundamental shift. It is not about automating the creator but augmenting them by handling the laborious aspects of generation and iteration. AI allows human experts to operate at a higher level of abstraction, curating, editing, directing, and applying strategic judgment. The synergy between human intuition and machine-generated possibility is forging a new frontier for innovation, where the only limit is the quality of our questions, not the cost of exploration. Part 2, AI in Practice, Functional Applications. Chapter 9, Human Resources and Talent Management. This chapter examines the transformative impact of AI on the most valuable asset of any organization, its people. AI is reshaping HR from a primarily administrative function into a strategic, data-driven powerhouse for attracting, developing, and retaining talent. However, this domain also carries significant ethical weight, requiring a careful balance between efficiency and humanity, insight and intrusion. Intelligent talent acquisition, sourcing and screening candidates. Core concept: AI streamlines the recruitment life cycle by automating time-consuming tasks, proactively identifying potential candidates, and providing data-driven insights to hiring managers. This aims to move from a reactive process of sifting through applications to a proactive one of talent discovery. How it works and examples: sourcing, AI tools scan platforms like LinkedIn, GitHub, and professional databases to find passive candidates whose skills and experience perfectly match open roles, even if they aren't actively job-seeking. Screening, natural language processing, NLP, algorithms can rapidly analyze thousands of resumes and applications, ranking them based on fit for the roles, required skills, experience, and even cultural indicators. Chatbot engagement, AI-powered chatbots can conduct initial screening conversations with applicants, answer their questions about the role and company, and schedule interviews, providing a responsive candidate experience 24/7. The value proposition dramatically reduces time to hire, lowers recruitment costs, expands the talent pool beyond active applicants, and ensures a more consistent and efficient initial screening process. Reducing bias in hiring core concept. This is a critical and double-edged application. While AI has the potential to reduce human bias by focusing on objective skills and qualifications, it can also perpetuate and even amplify existing biases present in its training data. The goal is to use AI as a tool for fairness by design. The risk: if an AI is trained on historical hiring data from a company that historically hired more men for technical roles, it may learn to downgrade resumes containing words associated with women's colleges or organizations. Mitigation strategies and ethical application. Bias auditing. Regularly testing algorithms for disproportionate impacts on protected groups. Focus on anonymization, using AI to redact personally identifiable information, name, age, gender, address, from applications during initial screening to force a focus on skill-based matching, designing systems to match candidates based purely on verified skills and competencies required for the job, rather than pedigree or vague cultural fit. The value proposition. When implemented ethically, AI can help build more diverse and inclusive workplaces by forcing an objective, skills-first evaluation and mitigating the unconscious biases of human recruiters. Personalized learning and development pathways. Core concept. AI curates hyper-personalized learning experiences for employees, moving away from one-size-fits-all training programs. It identifies skill gaps, recommends relevant content, and adapts learning pathways in real time based on an employee's role, goals, and learning style. How it works and examples. Skill gap analysis. AI analyzes job descriptions, performance reviews, and project outcomes to identify the skills an individual or team needs to develop to advance their careers or meet organizational goals. Content curation. An AI platform might recommend a specific micro-learning video, online course, or internal article to an employee based on their identified gaps and career aspirations. Adaptive learning. The AI adjusts the difficulty and pace of training materials based on how quickly the employee is mastering the concepts, similar to adaptive learning platforms in education. The value proposition. Creates a culture of continuous, relevant learning, increases employee engagement and retention by investing in their growth, and ensures the organization's workforce has the skills needed for the future. Employee engagement and sentiment analysis. Core concept. AI provides a real-time, nuanced pulse on employee morale and engagement by continuously analyzing feedback across various channels, moving beyond the once-a-year employee survey. How it works and examples. Survey analysis. Using NLP and sentiment analysis to parse open-ended responses in engagement surveys to identify common themes, frustrations, and praises. Passive feedback analysis. Anonymously analyzing communication patterns, e.g., email, collaboration tools like Slack or Teams, to gauge overall stress levels, collaboration quality, and organizational energy. This requires extreme caution and transparency to avoid being perceived as surveillance. Exit interview analysis. Systematically analyzing reasons for departure to identify systemic issues within specific teams or managers. The value proposition. Provides HR and leadership with actionable, real-time insights into the health of the organization, allowing them to address problems proactively such as manager training, workload balancing, or improving benefits before they lead to widespread disengagement or attrition. Predictive analytics for retention and attrition. Core concept. AI models predict which employees are most at risk of leaving the company, allowing managers and HR to intervene proactively with retention strategies. How it works. The model analyzes hundreds of potential data points looking for patterns that have preceded departures in the past. These can include engagement data, decline in survey scores, decreased participation in optional events, productivity data, unexplained changes in work output, behavioral data, increased use of sick days, decreased activity on collaboration platforms, a change in network of internal contacts, e.g., becoming more siloed. Ethical application. This is a highly sensitive application. It must be used to offer support, not punishment. The goal is to understand if an employee is disengaged, overworked, or looking for new opportunities so a manager can have a supportive conversation. The value proposition. retaining top talent is far less costly than recruiting and training replacements. Predictive attrition models allow organizations to preserve institutional knowledge, maintain team stability, and save significant resources by focusing retention efforts where they are needed most. Chapter summary: AI in HR represents the ultimate blend of data and humanity. Its responsible application can create a more efficient, fair, and engaging employee experience from hire to retire. However, its power demands a strong ethical framework. The goal is not to create a cold, automated system of human management, but to use data-driven insights to empower HR professionals and managers to be more empathetic, proactive, and strategic in fostering a thriving workforce. Part 3, Implementation and Strategy. Chapter 10, Building Your AI Strategy, a Blueprint for Leaders. An AI strategy is not a standalone document, it is a core component of your overall business strategy. It translates the potential of artificial intelligence into a concrete plan for creating competitive advantage, optimizing operations, and unlocking new value. This chapter provides a framework for leaders to construct that plan, identifying high-impact use cases. The journey begins not with technology, but with business problems. The goal is to pinpoint where AI can deliver the most significant value with the least initial risk. Start with your business objectives, align AI initiatives directly with top-level goals, increasing revenue, reducing costs, improving customer satisfaction, or mitigating risk. Map pain points and opportunities, inefficiencies. Where are there repetitive, manual tasks ripe for automation, e.g., data entry, invoice processing, customer service queries? Bottlenecks. Where is decision-making slowed by a lack of insights, e.g., loan approvals, diagnostic imaging, supply chain disruptions? Personalization. Could customer experiences be dramatically improved with tailored recommendations, content, or support? Prediction. Where would forecasting demand, predicting machine failure, or identifying customer churn be tremendously valuable? Prioritize with a impact vs feasibility matrix. Plot potential use cases on a 2x2 grid. Y-axis, business impact, high to low, e.g., revenue gain, cost savings, strategic importance. X-axis, feasibility, high to low, data availability, technical complexity, required investment, organizational readiness, quick wins, high impact, high feasibility. Start here. These projects build momentum and demonstrate value fast. Strategic initiatives, high impact, low feasibility. These are your moonshots. Plan for them with longer-term investment and phased approaches. Avoid projects that are low impact, regardless of feasibility. Example, a manufacturing company might identify predictive maintenance, preventing downtime, as high impact, and generative AI for designing new products as a more complex, strategic initiative. Assessing readiness and building a business case. Before seeking funding, conduct a clear-eyed assessment of your organization's readiness and build a compelling business case. The 4 pillars of readiness. 1. Data readiness. Do we have access to the necessary data? Is it clean, labeled, and sufficient in volume? Is it governed and accessible? 2. Technology readiness. Do we have the infrastructure, cloud, compute power, to develop and deploy models? What is our current IT landscape? 3. Organizational readiness. Does our culture embrace data-driven decision-making? Are business units prepared to adopt new AI-powered workflows? 4. Talent readiness. Do we have in-house skills, data scientists, ML engineers, AI ethicists, or a plan to acquire them? Building the business case. Executive summary. Clearly state the problem, the proposed AI solution, and the expected value. Problem definition. Detail the specific business pain point or opportunity. Proposed solution. Describe the AI use case at a high level. Financial justification, costs, development, internal and external, software/licensing, cloud infrastructure, change management/training. Benefits, quantifiable, increased revenue, reduced operating